EV battery recycling is important for a number of reasons. Firstly, it allows us to conserve valuable resources like lithium and nickel, which are essential for battery production but limited in supply. Also, recycling reduces the need for new mining, which can be environmentally damaging. We see a future at Altilium where there's limited amount of mining. For example, 2040, you have more lithium coming from recycling than primary mining. But of course, between now and then, you need a lot of mining with good ESG. Secondly, it enhances supply chain security. Many critical battery minerals are sourced from regions with political and environmentally challenges. So it gives a domestic, stable source of materials to the US, Europe, and the UK. And also it allows us to build a circular economy where materials are reused, we reduce costs and emissions in the long term, and also the environmental impact. Next slide, please. By 2030, Europe's gigafactory capacity is set to soar to around 1,350 gigawatt per year, with 38 plants expected to be operational. Germany leads with 7 gigafactories, followed by Hungary and France. Globally, there's approximately 400 gigafactories planned. That represents a pipeline of 9,000 gigawatt hours in lithium-ion battery capacity. The battery cell components market is expected to hit $250 billion US dollars by 2030. In the UK, Agratas, which is Tata Sun Venture, is investing over 5 billion US in a 40 gigawatt gigafactory, and the main customer is JLR. We have ASC in the northeast of the UK with 15.8 gigawatt plant. So what we see is there's an emerging gigafactory battery production complex starting in the UK. Next slide, please. If we look at the UK battery industry, we see significant growth beyond 2030 as the UK and global demand for EV rises. This isn't only driven by EVs, but also larger battery capacities required for heavy vehicles like buses and HGVs. By 2040, the UK needs 200 gigawatt hours of battery supply to meet demand across private cars, commercial vehicles, and grid storage. This is equivalent to the output of 10 gigafactories, circa 20 gigawatt hours annually. So, the UK is looking to capture share through, battery startups and attract global manufacturers, and it's a great opportunity for the UK. Next slide, please. So what we see is that, and I kind of touched on this in the teaser, that there's European regulations forcing automakers to close the loop on an EV battery supply chain. There's regulations coming which are designed to enhance battery collection targets, set minimum recycling efficiencies, and minimum levels of reuse. By 2030, new batteries must include 6% lithium, 6% nickel, 16% cobalt. These targets, increase significantly in 2036. So, even automotive OEMs and battery manufacturers that don't meet these requirements risk being excluded from the EU market. And the basis of the European Union doing this is to, secure a stable supply of recycled materials and to onshore battery supply chains. And also in the UK, the largest automotive manufacturers such as Nissan, export over 50% of their vehicles to Europe. So they're bound by these initiatives as well. Next slide, please. So from a regulatory perspective, there's a number of initiatives from the UK government to support a circular economy for batteries. So we have a UK critical mineral strategy and a battery strategy, which focuses on recycling to reduce pressure on primary supply. Also in the UK, we have the ban of new petrol and diesel cars from 2030, which will accelerate the number of batteries for recycling. We have a grant ecosystem in the UK. It's probably not as developed as an Inflation Reduction Act in the US, but from our side at Altilium, we've received over 10 million US dollars from the UK government to develop green processing technologies and scale up green processing technologies. There's over 2.5 billion committed over the next years to build a UK battery supply chain. And I think as Altilium, we're in a good position to commercialize technology and build at scale battery recycling plants with government grants and loans. Next slide, please. As a batteries materials development company, we have access to the UK Battery Industrialization Centre. We see this as quite unique in the UK. This allows startup companies to join the link between battery technology, which we can prove at bench or pilot scale, to having access to a gigafactory to show and demonstrate mass production. So this is publicly funded, and we're actually using this as part of our scale up, which I can talk about a bit in a moment. Next slide, please. So, our approach to battery recycling is kind of driven by a customer requirement to have end-to-end solution. So, we can collect an EV battery, we transport it with zero carbon. It then gets recycled to black mass, and then, it goes on for chemical refining to create battery metal salts, PCAM and even CAM. So we see the UK market is quite unique. Essentially, the UK is an island. We don't see a scenario where batteries are exported into Europe. We see a scenario in the future where black mass will stay in the UK. With this energy transition, it contains the critical minerals, which are almost strategic assets of the UK. We have the largest second-hand car market in Europe. We have the second highest adopter of EVs in Europe, and we have over 1 million vehicles registered in the UK. Next slide, please. So at Altilium, we're scaling up to mega scale battery recycling in a controlled way. I think what we've seen is some of the projects in the US have had scale up risk. So essentially, we've started with a pilot line. This allows us to produce kilogram levels of salts, PCAM and CAM, and mainly the work we're doing, which we talk about in the moment, is around qualification of those materials with automotive OEMs. We're in the process of building a mini commercial plant which processes 1 EV battery per day, and that is metric level tons of PCAM and CAM. That comes online December this year. We're just finalizing the environmental permit. Next slide, please. existing in the group, we have a brownfield solvent extraction electrowinning hydromet plant, which is fully permitted. We're in the process of retrofitting that plant. It will process battery waste from 24,000 EVs. As part of the scale up, we're going to essentially the first stage of our process, which is a production of a nickel MHP and also a lithium sulfate product. Next slide, please. And all of this work is actually leading to us towards what we call Act 4. So we're Altilium Clean Technology. So this is facility number 4, and this is based in the northeast of the UK. This is almost mega scale battery recycling, co-located in the heart of the new UK gigafactory industry that's been built. At the moment in the UK, we're the only company which is looking at scale hydromet recycling capacity, and also going to PCAM and in the future CAM. The size of this plant is over 150,000 EV batteries, and will produce in the latter stages 21,000 metric tons of CAM, which is circa 20% of the UK's requirement in 2030. And this location, Teesside, is not only a premier location for battery recycling in the UK, but for Europe as a whole, because there's a number of advantages around location, energy, and human resources. Next slide, please. So Teesside's the largest chemical park in the UK and has access to low-cost green energy. It has Europe's largest wind energy projects, and also there's a large BP green hydrogen project. It's also close to Nissan and ASC. ASC have pledged to build 3 gigafactories in the UK going forward. Also this location is optimized for logistics. We can deliver material throughout the UK, but also we're only 24 hours from the German automotive heartland. Next slide, please. So, actually, this, we see this industry is around decarbonizing supply chain. So, our moonshot is the lowest carbon, the most eco-friendly raw materials. An EV battery contributes approximately 35% of the total emissions in EV production. So they're a low-cost option for decarbonization. The green processing technologies which we've developed allow us to reduce the carbon by circa 67% by recycling production scrap and old EV batteries in the UK, compared to cathode active material coming in from China, which is the predominant supply chain at the moment, and that's from virgin mining. And if we look at the anode material, on our third party LCA, we have a 77% reduction in carbon. So this becomes important for automakers as they decarbonize their fleets. And the automakers we're working with have targets, for example 2040, a zero carbon EV. Next slide, please. So if we talk around battery recycling technologies, the incumbent pyrometallurgical industry, which is the incumbent industry in Europe, which was built around the consumer scrap, it only operates at 50% efficiency and traditionally fails to recover lithium. So the new European regulations mandate minimum lithium recovery of over 80%, meaning new capacity and new technologies need to be adopted. And what we're seeing is that for at scale battery recycling, we look at hydromet. How we think about battery recycling at Altilium is that we need to do it at the largest scale we can to the highest value component. And of course, we have to control the upstream feed, the black mass, for quality reasons as well as security of feed. Next slide, please. So if we talk around the technical leadership which we've developed in the UK and the innovation in green processing technology, a lot of this work is being done at our EV battery recycling technology center, where we've developed the flow sheet. We're doing a lot of work on how we increase the efficiencies of recycling, particularly for lithium, how we maximize the margins or the payables, and how we look at reducing capex and opex. I think as other recyclers, we can process a range of different chemistries. We LCO, LFP, NMC. We can even process primary MHP. We see that in the early days for very large scale battery recycling, scrap might be tight. So for imbalances in quality and quantity, we will process primary MHP, but the primary MHP is with good ESG, non-Chinese supply chain, and of course we're a sustainable raw material supplier. But we can recover over 95% of the cathode metals for re-engineering. We see that the cost of at-scale battery recycling is 20% lower compared to cathode active material from virgin raw materials. One thing which is setting us apart from our competitors is our focus on sustainability. The flow sheet which we've developed, we believe, is a 60% lower sodium sulfate waste stream compared to our competitors. And what we're seeing in some parts of the world, that the sodium sulfate waste stream is becoming an issue for new battery startups, and we've seen that in the US. Next slide, please. So I think, look, what we want to articulate here is that, as well as recycling batteries, what we're doing is upcycling batteries as well. Some of the work we're doing with Nissan is we're taking 11-year-old Leaf batteries, NMC 111 chemistry, and what we do is upcycle to a very new chemistry such as an NMC 811. So this is around meeting customer requirements and taking a wide range of scraps and then being able to deliver one product to put back to build new batteries. Next slide, please. So we're one of the few recyclers which are looking at anode circularity as well as cathode circularity. A lot of the focus has been on the cathode circularity. We can recover in our process 99% of the graphite. Graphite is maybe 40% of the content of the black mass, so it becomes quite important to make to make battery recycling profitable, to have a payable on the graphite. So For the last 18 months, we've had a development program with Talga. Talga is a European anode producer and has the largest graphite mine in Sweden. We've been able, we're on our 4th generation graphite product now. Essentially what we are doing is some post-treatment steps. And what we have heard from Talga, that this can now be put through their flow sheet in the same way as their natural graphite. So they're in the process of producing anode materials for testing under that program. I think what we're seeing is a lot of recent interest in alternate sources of graphite. If we look at a Chinese dominated supply chain, graphite is very heavily controlled by China, and they started to frustrate the supply of graphite basis export licenses. So yeah, what we're seeing is a number of parties becoming interested in graphite from battery recycling. And another point is that putting on primary graphite, if you look at the permitting timelines, they can be quite long. If we do battery recycling in a chemical park, and battery recycling is really at scale chemical processing, we can be permitted in the UK in 9 to 12 months. Next slide, please. So this is just some of the work we're doing with our partners and future customers. And as I mentioned before, we've had some very positive support from the UK innovation agencies to develop and scale up technology. So we have one program which is called APC 23. This is with Nissan and AESC. So what we're doing is taking production scrap and their old batteries and creating a modern NMC 811, which is we're doing some very simple laboratory coin and pouch cell testing, showing the performance of recycled material is the same as commercial CAM. As I mentioned, we have access to the UK BIC gigafactory, so we're delivering at scale quantities of CAM. Actually, this CAM material is what we call -2036, which is the 2036 regulation for minimum recycled content. And at the moment, UK BIC are in the process of producing 100 pouch cells. And actually, those cells then go on to Jaguar Land Rover under another program, which will essentially qualify those cells as a saleable product in their I-PACE vehicle. And within that program, there's a big focus on the carbon reduction in a I-PACE battery based around using a recycled domestic material produced in the UK versus a Chinese supply chain. And the end of that program is next year. We have an exhibition called Cenex in the UK, which is a low carbon vehicle exhibition. And there what we will do is show a battery module, which has been, and the results of the qualification from battery recycling. Next slide, please. So, we see that to get to net zero, we need to collaborate. I think this initiative and forum is excellent, and it's great to be part of the battery ecosystem which is being built globally and in the West. One thing we have at Altilium is a positive sense of urgency. What we're ultimately looking to do is to supply the UK domestically with high volumes of anode and cathode material to put back into a supply chain to electrify transport and the grid. There is no time. There is no 2050. All of the infrastructure needs to be built by 2030. So that is kind of driving us forward. So any opportunities or ideas to collaborate, I think you can see my my contact details. So please reach out to me. And I hope that was interesting, and you learned some more about the small island of the UK and the work we're doing in battery recycling. And happy to answer any questions.